Hello, and welcome to this module on viruses and worms. Let's see what we'll be covering. We'll start with what is a virus or a worm, then move on to a discussion on how viruses or worms are created, what types of viruses and worms exist, how viruses and worms spread, and then finally we'll end up with what countermeasures are in place and need to be avoided as a penetration tester. Great, let's move on. Okay, so what is a virus and what is a worm? Well, they're both forms of malware, and if you recall from the previous module, Trojan is also malware. So all of these things sort of melt together, and you can get viruses that have Trojans, you can get worms that are Trojans, and they all sort of blend. So you get what's called a blended malware attack. But for the sake of definition, let's look at what is a virus and what is a worm, because we've already defined what a Trojan is. Okay, great. So what is a virus? Okay, so very important here. A virus is a type of malware that is capable of replicating by reproducing itself. So that is very important. So that's the difference between Trojan, a true pure Trojan, and a virus. A virus can replicate itself. In other words, it can copy itself onto a memory stick and be spread around, whereas a Trojan needs to be activated. Now, a Trojan could be a payload in a virus, but it doesn't necessarily have to be. So a virus can spread itself around, and very important, by a user's action. In other words, the user has to click on something, has to put in a flash drive, has to connect to a network, has to go to a website, etc., etc. So that is a virus. Now, a worm is very similar to a virus, and a worm is also capable of replicating itself, but it can do it without a user's action. So worms are a little bit more dangerous, and there have been quite a few worms a couple of years ago. If you recall the amount of email worms that were spread at a point in time. So what a worm does is it automatically looks for vulnerabilities in a network or a system and then can spread itself. As long as you're connected to that network, you don't have to do anything. Just by plugging into a network, you'll be pretty much infected with worms. So let's move on. Great. So the virus and the worm always has two parts to it. It always has something that allows it to replicate and reproduce itself and copy itself or whatever it is, or spread via vulnerabilities. And it always has a payload. Now the payload could be a Trojan, it could be a rootkit, it could be anything that you put in there. But the important thing to remember is the replication is what differentiates a worm and a virus from a Trojan, because it is able to replicate itself and spread by a user or spread without a user, for in the case of worms. And then you get a virus or a worm. Great. Let's move on to the next slide. Great. So how are viruses and worms created? Well, this picture is worth 1,000 words. They're generally created by computer virus kits. There is millions upon millions of viruses out there, and there's just more and more being produced every day. And the majority of them are produced using computer virus kits that you can download off the internet. I'm actually going to show you a few in the demo coming up. So as you can see, literally it's just a pure graphical user interface. You just put in all the information you want, you put the payload you want, you click on make, and literally a virus or a worm is created for you. So that is why if you look at your antivirus signatures, you'll see multiple variants of a single virus family. That's because they are all generally generated off a single kit, and then every malware script kiddie who changes a few settings here and there slightly changes the the MD5 hash, which is used to identify the actual malware by the anti-malware engines. So there are still pure viruses being written, but those are written by really, really smart and clever individuals who can create viruses literally by writing code, and those are the true virus creators. But like I said before, the majority actually come from computer virus kits, such as the example on the screen now. Great, let's move on to the next slide. What types of viruses and worms exist? Well, as I said before, there are millions of viruses being created and millions of viruses out there. And this is a huge area of specialization in computer security, so this course is literally going to scratch the surface. So if you want to learn more about viruses and worms, you can go to the websites of the anti-malware companies and look at their virus dictionaries or virus encyclopedias as they call them, and you'll see how many variants and how many different types of viruses are there. Let's just go look at a few of the examples I have here. So we've got boot sector viruses, which are viruses that infect the boot sector of your Windows PC. So when you boot up, you are automatically infected before you even log in. You get file and multipartite viruses. Those are viruses that exist in the file system and are activated when you click on a file or when a file is executed by a running program. You get macro viruses, which pretty much run on Microsoft Office documents such as Word, Excel, etc., but run in the macro. In other words, they run VBScript. So as you may have noticed over the years, as you open more and more Office documents, it always says this workbook is protected. Are you sure you want to enable macros? And it's literally because of this issue in the industry that they've had to actually put that safeguard in. You also get polymorphic viruses. Now, polymorphic is just a way of viruses hiding, and what a polymorphic virus does is it actually mutates every single time it replicates itself. It adds a little bit of code to itself so that its MD5 hash, in other words, the hash that's used by anti-malware agents to identify it, changes every single time it replicates, which makes it very, very difficult to eradicate. And then finally, you get shell viruses, which sits in the kernel or in the shell of the computer. Alright, let's move on to the next slide. How are viruses and worms spread? Well, before we get to how they are actually replicating and spreading, let's look at which platforms are the most vulnerable to viruses. By far and wide, the largest amount of viruses are written for the Windows operating system. Why? Well, because the Windows footprint out on the internet in the world is very, very large. Over 90% of PCs run Windows. So if you want to infect something, it would make sense for you to write something that is so widely used across the internet, across the world. And that's pretty much why Windows is. It doesn't mean that Mac or Linux is any less vulnerable than Windows. It's just there's been a very big focus by the malware authors on Windows because of its large footprint out globally. Next up is Android. Okay, so Android is the operating system, mobile operating system by Google or owned by Google, and because of the way Google manages their Play Store, which is the App Store for Android, there are multiple times, and if you read the press or just follow the industry journals, you'll see there are many times they've had to take apps off the Google Play Store because they are actually infected with malware. So, and from a mobile footprint, Android is by far the largest operating system, so once again it will be the largest target. So Android is probably the second largest platform for viruses. And then Mac OS and Linux, they're pretty much on par. There are a few viruses that are written for Mac and Linux, so please don't think that you are safe running those. You are safer, but if somebody wants to infect you, they will infect you because there are vulnerabilities in those operating systems. And finally, iOS, which is probably the least vulnerable operating system out there for viruses and worms. Okay, let's move on and see how they spread. Malvertising. Okay, so malvertising is literally just a made-up word by the industry. It's a combination of malware and advertising. And recently there have been many sites that where people put infectious adverts that have some JavaScript in the background and then attack your browser using cross-site scripting and infect you in that way. Then there's clickjacking, which is similar to malvertising. What they do there is obviously there's when you click on a link, instead of taking you to a page, it also opens up a pop-up in the background, which also infects you using cross-site scripting. Phishing. So as always, if somebody wants to have a targeted attack or get the viruses out there, they send a phishing campaign out hoping that some users will click on an attachment or in most cases a link that will take you to a site which should then infect your machine once again using a browser exploit. Open network. So Wi-Fi is always great. Free Wi-Fi is even better. But I mean, you must be very, very careful because that is a hunting ground for malware authors because it's a watering hole. Think of a watering hole out in the African um, savannah where animals come to drink, but that's the best place lions come to attack as well. Same thing with virus authors. If you've got free Wi-Fi, you need to protect yourself because there's a good chance there might be a worm floating around there. So make sure your firewall's on and make sure that your malware is up to date. And that's pretty much the countermeasures that we as penetration testers need to take into account when trying to evade these countermeasures. App stores, as I said before, Android's a very big marketplace for malware and it's just growing more and more. So be very careful downloading apps from the Play stores. Make sure that they are written by reputable authors and are signed and certified, etc., by the operating system. And then finally, software downloads. As always, any downloaded software off the internet must be scanned, and that is a very, very big vector for viruses and worms to actually take place or take a hold and then spread from there. Great. Let's move on to the countermeasures. So, how do people put in countermeasures against viruses and worms? Well, as a protector, these are the technologies and processes that you need to use, but as a penetration tester, you need to be aware of these policies and procedures and software and technology that people use to protect themselves, because if you want to use a virus or a worm as an infection or as a vector to get into a network or a system, you need to be aware that these are the countermeasures that are in place that you will need to evade at some point in time. Okay, let's move on. So, anti-malware. It's a long industry. It's been around probably since operating systems have been around, since the early 80s, mid 80s I'd say. And basically there are really robust enterprise class anti-malware engines and services out there that do signature-based detection, and the latest trend is to actually use anomaly detection. So what the anti-malware engine now does is it monitors your computer's use, what it does on a normal basis, and if it sees anything out of the ordinary, it then stops that and alerts you, which is using a little bit of, I suppose you'd call it, artificial intelligence, in that it's looking for behavior. Because there are so many different malware variants out there and the signatures can't keep up, the guys are now starting to look at behavioral analysis and alerting on abnormal behavior. In other words, if something's making a connection to the internet, it'll tell you something's trying to make a connection to the internet because it is abnormal for this machine to want to do X, Y, or Z. And that's pretty much how it works. Then there's the standard email attachments monitoring and email link monitoring, and that pretty much works on a server level as well as a client level. A lot of Outlook is an example of an email client, but a lot of email clients out there now warn you before you click on a link to make sure that you know that that link is actually going to a site that you are aware of and that you want to go to, instead of some site that's infected with malware. And then patch management. A lot of viruses take advantage of exploits, and the exploits are written for vulnerabilities, so patching your systems protects you, and understand that. So obviously as a penetration tester, you're going to look for an unpatched system where the vulnerability still exists. Then we move on hardened servers and services. Some malware and worms are activated by certain services. So if we make sure that our servers are only running the bare minimum services that need to be running, it also helps to protect against malware infection. And then training. Training is probably the most important thing here, but it's the countermeasure that's done the least is actually end user training. Training your users not to click on links, training your users not to download software. It's very important for user security awareness and to prevent infection. And then finally, anomaly analysis, which is what I covered in the anti-malware section at the top. Basically, we look at systems, we look at services, and we start to baseline how they work, and then we look for anomalies to make sure that if something is acting out of the ordinary, that it isn't some sort of malicious software running in the background. And that brings us to the end of this video. Thank you for watching.